Look at a bustling riverbank. Life happens in two distinct directions. Up in the branches, a heron stands watch, while an otter hunts below. If we try to keep records of where these animals are using only basic positive numbers, we quickly run into a problem. Say our ledger simply reads that the otter is at 4 spans high in a tree, or 4 spans deep in the water. By noon, nobody reading the record knows who is wet and who is dry. To fix this, we need a single decision that gives every number a specific meaning. We have to agree on a starting line. Before any number can tell you a physical direction, you have to decide exactly where 0 is. And in the natural world, that 0 point is a choice. Let's make the water's surface our 0. Suddenly, the entire ecosystem is split cleanly into above and below. The heron's perch is now marked as positive 5 spans, 5 units above the water, and the otter's hunting depth becomes negative 4 spans. Notice that the negative sign doesn't mean the otter has a lesser value than the heron. It strictly tells us to look downward from our agreed-upon line. If another bird flew 4 spans above the water, at positive 4, it would form a mirrored pair with the otter. Positive 4 and negative 4 are exact opposites, the exact same distance from 0, just on opposite sides. By setting a strict physical boundary for 0, the plus and minus signs become navigation instructions. This logic applies to entirely different situations, like a squirrel tracking her winter food. Here, 0 doesn't mean no acorns. 0 is her break-even point, the exact number of acorns she had the day she started tracking her stash. Take a look at this vertical chart tracking her inventory. If she locates a new cache of acorns, we log a positive 7. She is 7 acorns ahead of where she started. But later, a jay raids the cache and steals 10 acorns. The ledger drops 7 acorns just to get back to 0, and then continues downward for 3 more. It lands at negative 3. She isn't holding negative 3 physical acorns in her paws. The sign tells a specific story. She is 3 acorns behind her starting stock. We can even use this system to measure invisible states, like the temperature on a frosty winter morning at the riverbank. Look at this gauge. On a winter thermometer, 0 is defined as the exact threshold where water freezes into ice. At dawn, the reading sits at negative 6 degrees, dropping well below the freezing line where the puddles turn hard. By noon, the sun warms the air and pushes the reading up to positive 9. The ice melts, leaving mud everywhere. This creates an interesting comparison. Which temperature is colder, negative 2 or negative 6? The bare number 6 looks larger than 2, but negative 6 sits a greater physical distance down the line, deeper into the freezing zone. Plotting values spatially like this removes the guesswork. Farther down is always less, above and below the water surface, ahead and behind break even, warmer and colder than freezing. 3 totally different physical realities, all running on the exact same mathematical machine. To use it, you just have to ask one question before looking at the data. What does 0 mean in this specific situation? Once you establish that baseline, the positive and negative signs immediately snap into focus as physical directions. And with those directions locked in, you have the logic you need to plot any integer precisely onto a formal mathematical number line.